सब्सक्राइब कीजिए चैनल स्नेहलता शर्मा को और बेल आइकन को दबाइए लेटेस्ट वीडियो सबसे पहले देखने के लिए।
हेलो स्टूडेंट्स, वेलकम बैक। स्वागत है आप सभी का। बच्चों, आज इस वीडियो में हम क्वाड्रिलेटरल्स चैप्टर की एक्सरसाइज 8.2 के क्वेश्चन नंबर 1 एंड क्वेश्चन नंबर 2 डिस्कस करेंगे। आइए स्टार्ट करते हैं क्वेश्चन नंबर 1 से। क्वेश्चन नंबर 1, ABCD is a quadrilateral in which P, Q, R and S are midpoints of sides AB, BC, CD and DA respectively. See figure. This is figure. In this figure, we have midpoint of AB. This midpoint is P. We have midpoint of BC. This is Q. Midpoint of CD. This is R. And midpoint of AD is S. Also, AC is a diagonal. Now, we need to show that part 1, SR is parallel to AC and SR is equal to half of AC. Part 2, PQ is equal to SR and PQRS is a parallelogram. So, to prove that SR is parallel to AC, we will consider triangle ADC. This is triangle ADC. In triangle DAC, we have R is the midpoint of DC and S is midpoint of DA. Thus, by midpoint theorem, SR is parallel to AC and SR is equal to half of AC. Let's write all this. In triangle DAC, this is triangle DAC. In this triangle, we have R is midpoint of DC, this is given. S is midpoint of DA, this is also given. Thus, by midpoint theorem, we have SR is parallel to AC and SR is equal to half of AC. By midpoint theorem. इसको फिगर में देखिए, SR is parallel to AC. Now we will consider triangle ABC. So in triangle BAC, figure में देखिए, this is triangle BAC. In this triangle we have P midpoint of AB and Q midpoint of BC. Thus by midpoint theorem we can say that PQ is parallel to AC and PQ is half of AC. Let us write P is midpoint of AB, this is given. Q is midpoint of BC. This is also given. Thus, PQ is parallel to AC and PQ is equal to half of AC by midpoint theorem. Now, we have PQ is parallel to AC. Also, SR is parallel to AC. Since these two lines are parallel to same line, it means SR is parallel to PQ. Let us do. We have SR is parallel to AC and PQ is parallel to AC. Now, look at figure. Here we have SR, this line is parallel to AC and also PQ is parallel to AC. Since two lines are parallel to the same line, it means these lines are parallel to each other. Therefore, SR is parallel to PQ. Also, SR is equal to PQ because SR is equal to half AC and PQ is equal to half AC. Let's write. Thus, PQRS is a parallelogram because a pair of opposite side of quadrilateral PQRS is equal and parallel. Hence, proved. Next करते हैं question number 2. Question number 2. ABCD is a rhombus and PQRS are midpoints of the sides AB, BC, CD and DA respectively. Show that quadrilateral PQRS is a rectangle. See figure. In this figure, it is given that ABCD is a rhombus and PQR and S are midpoints of sides AB, BC, CD and DA respectively. Now we need to prove that PQRS is a rectangle. Let us do. Given ABCD is a rhombus and PQRS are midpoints of sides AB, BC, CD and DA. To prove PQRS is a rectangle, construction, join AC and BD. Now proof. To prove that PQRS is a rectangle, we need to prove that PQRS is a parallelogram with each angle 90 degree. It means we need to prove that this angle is 90 degree. So let's start this with triangle DRS and triangle BPQ. In triangle DRS and triangle BPQ, see figure, these are triangles DRS and triangle BPQ. In these two triangles, we have DS is equal to BQ. This is side DS and this is side BQ. Because these are half of the opposite sides of rhombus. So these sides will be equal. Angle SDR, this angle is equal to this angle because these are opposite angles of rhombus and are equal. Also we have DR, this side DR is equal to this side BP. So by SAS congruence rule, we can say that these two triangles are congruent. And by CPCT, we can say that RS, this is RS and PQ, these are equal. So let us write all this. In triangle DRS and triangle BPQ, we have ds is equal to bq, half of the sides of rhombus. Angle SDR is equal to angle QBP. These are opposite angles of the rhombus. Also, we have dr is equal to bp because half of the opposite sides of rhombus. Therefore, triangle DRS is congruent to triangle BPQ by SAS congruence rule. This gives RS is equal to PQ by CPCT. Let us mark this as equation 1. Now we will consider triangle QCR and triangle SAP. In triangle QCR and triangle SAP, see figure, these are triangle QCR and triangle SAP. In these two triangles, we have RC is equal to PA, this is RC and this is PA. These two sides are equal. Similarly, we have AS is equal to QC. These two sides are also equal because these are halves of the opposite sides of rhombus. Also, we have this angle is equal to this angle because these are opposite angles of rhombus. So, these two triangles, triangle SAP and triangle QCR, will be congruent by SAS congruence rule. Let us write all this. We have RC is equal to PA, halves of the opposite sides of rhombus. Also, angle RCQ is equal to angle PAS. These are opposite angles of rhombus. Also, we have CQ is equal to AS because halves of the opposite sides of rhombus. By these three, we can say that triangle QCR is congruent to triangle SAP by SAS congruence rule. So, by CPCT, we can say that RQ is equal to SP by CPCT. We will use RQ is equal to SP later on. Let's mark this as equation 2. We will use this later on. Now consider triangle CDB. In triangle CDB, see figure, this is triangle CDB. In this triangle, we have R, this is midpoint of CD, and we have Q, this is midpoint of CB. So by midpoint theorem, we can say that QR is parallel to BD. Let's write this. In triangle CDB, R and Q are midpoints of CD and BC respectively. Therefore, QR is parallel to BD. Let's mark this as equation 3. Also, P and S are the midpoints of sides AB and AD respectively. This gives PS is parallel to BD. You can see figure, this is P is midpoint of AB and S is midpoint of AD. This point is S. Now PS is parallel to BD. Let us mark this as equation 4. Now consider equation 3 and equation 4. Here we have QR is parallel to BD. If you look at the right hand side, QR is parallel to BD and BD is also parallel to PS. See figure. So we have QR is parallel to PS. So QR will be parallel to PS. Thus PQRS is a parallelogram because a pair of opposite sides of quadrilateral PQRS, that is QR and PS, is equal and parallel. You can see figure, this is QR and this is PS. QR is parallel to PS and these sides are also equal. So we can say that PQRS is a parallelogram. So this figure PQRS is a parallelogram. Now we need to prove that one angle of this parallelogram is 90 degree. To prove one angle is a right angle, we will consider parallelogram LM and Q. Consider ML and QN. This is ML, this is QN. These two are parts of parallel lines BD and QR. So these two will be parallel. Similarly, we will have LQ is parallel to MN because these are parts of parallel lines PQ and AC. So LM and Q is a parallelogram. Let's write all this. As LQ is parallel to MN and ML is parallel to NQ, this gives LM and Q is a parallelogram. Now in this parallelogram, we have angle LMN. This angle is equal to this angle, angle LQN, because opposite angles of a parallelogram are equal. Also, we have angle LMN is equal to 90 degree. So this angle is 90 degree because diagonals of a rhombus are perpendicular bisectors. So this angle is 90 degree and this angle is equal to this angle. It means angle LQN is also 90 degree. Let's write all this. Angle LMN is equal to angle PQR because these are opposite angles of a parallelogram. Angle LMN is equal to 90 degree because diagonals of a rhombus bisect each other at right angles. This gives angle PQR is equal to 90 degree. So we have proved that LMNQ is a parallelogram and one angle PQR is 90 degree. Now in PQRS we have RS is equal to PQ and RQ is equals to SP. See figure, this is PQ and this is RS. These two are equal. Also we have RQ is equal to SP. And one angle Q is a right angle. Angle Q is equal to 90 degree. Thus PQRS is a rectangle. Hence proved. I hope आपको ये दोनों क्वेश्चन समझ में आ गए हैं. बच्चों फिर मिलते हैं अगले वीडियो में इसी एक्सरसाइज के बाकी के बचे हुए क्वेश्चंस के साथ. थैंक यू ऑल.